In this video, we're going to look at the Nobel Prize for Chemistry for the year 1911, awarded to Marie Curie, née Skłodowska, for the discovery of the elements radium and polonium by the isolation of radium and the study of the nature and compounds of this remarkable element. Here you see the Nobel Prize diploma awarded to her, which is always, in my opinion, a work of art. Here you see some more explanation why she got the prize. After Marie Skłodowska-Curie and Pierre Curie first discovered radioactive elements polonium and radium, Marie continued to investigate their properties. In 1910, she successfully produced radium as a pure metal. This proved the new element's existence beyond a doubt. She also documented the properties of the radioactive element and their compounds. Radioactive compounds became important as a source of radiation in both scientific experiment and in the field of medicine, where they are used to treat tumors, which is still true today. Coming from the official Nobel site, here you see the link. Some biographical information then. Her early researches together with her husband were often performed under difficult conditions. Laboratory arrangements were poor and both had to undertake much teaching to earn a livelihood. The discovery of radioactivity by Henry Becquerel in 1896 inspired the Curies in their brilliant researches and analysis, which led to the isolation of polonium, named after the country of Mary's birth, and radium. Madame Curie developed methods for the separation of radium from radioactive residues in sufficient quantities to allow for its characterization and a careful study of its properties, therapeutic properties in particular. Madame Curie, throughout her life, actively promoted the use of radium to alleviate suffering, and during World War I, assisted by her daughter Irene, she personally devoted herself to this remedial work. She retained her enthusiasm for science throughout her life and did much to establish a radioactive laboratory in her native city, in Poland. Madame Curie, quiet, dignified, and unassuming, was held in high esteem and admiration by scientists throughout the world, and she was a member of the Conseil de Physique Solvay from 1911 until her death, and since 1922 she had been a member of the Committee of Intellectual Cooperation of the League of Nations. Her work is recorded in numerous scientific papers in scientific journals, and she is the author of Recherches sur les substances radioactives, l'isotopie et l'élément isotopique, and the classic Traité de radioactivity from 1904 and 1910. This is summarized by me. If you want to complete biographical information on the official Nobel website, then you have to follow this link. You see especially in present-day view, modest laboratory the Curies were working in. This is on the inside, of course. Here they investigated radioactivity in what is now considered, of course, primitive conditions, but nevertheless they did remarkable work. Then the award ceremony speech by Dr. E.B. Galgren, in recognition of the part she has played in the development of chemistry, by the discovery of chemical elements by radium and by polonium, by the determination of the properties of radium and the isolation of radium in its pure metallic state, and finally by research into the compounds of this remarkable element. In 1896, Becquerel observed that the compounds of the element radium gave off rays which he had the property of acting on photographic plates and of making air conduct electricity. If you want to read that story, go to the Nobel Prize for Physics for 1903. This phenomenon is known by the name of radioactivity, and the substances causing it are said to be radioactive. A little later it was noticed that the compounds of another element, thorium, already discovered by Berzelius, possess similar properties. For the discovery and investigation of this radiation called uranic or Becquerel rays, the Academy of Science awarded the Nobel Prize for Physics in the year 1903 to Henri Becquerel and Pierre and Marie Curie jointly. During research in the radioactivity of a great many compounds of uranium and thorium, Madame Curie realized that the strength of the radioactivity was directly related to the proportion of these elements in the compound. However, certain naturally occurring minerals provided a striking exception to this rule, for example, pitch blende, whose radioactivity was well above the value calculated from its uranium content, in fact even greater than that of the uranium element itself. The logical conclusion was that these minerals, must contain a heterodox, unknown element which was extremely radioactive, and in fact, by the systematic use of chemical processes, which were long and arduous and required several tons of pitch blende, Marie and Pierre Curie finally succeeded in extracting, admittedly in minute quantities, the source of these new highly radioactive, which they named polonium and radium. If you want to read that story, again, go to the Nobel Prize lecture of 1903. Radium, the one of these two elements, which it has been possible to isolate in the pure state so far, resembles the metal barium in its chemical properties, and it is distinguished by a very characteristic spectrum. Its atomic weight was determined by Madame Curie to be 226.45, and it was only last year, that is 1910, that Madame Curie, with the help of a co-worker, succeeded in producing radium in a pure state. That is, as a metal, thus establishing its status once for all as an element in spite of various hypotheses to the contrary. Radium is a silvery white shiny metal which decomposes water violently and charged organic matter such as paper with it comes into contact. It melts at 700 degrees Celsius and is more volatile than barium. From the chemist's point of view, the most remarkable property of radium and its derivatives is that without being affected by environmental conditions, they continually give off an emanation, a radioactive gaseous substance, which condenses into a liquid at low temperatures. This emanation, for which the name niton has been proposed, seems to have the characteristics of an element and chemically is most likely like the so-called noble gases, whose discovery was rewarded at the time with the Nobel Prize for Chemistry. This is not all. The emanation in turn undergoes spontaneous breakdown, and among the products of its breakdown, Sir William Ramsay, the Nobel Prize winner, and other leading scientists after him have established the presence of the gaseous element helium. This had already been observed in the solar spectrum and even found in small quantities on Earth. This fact has established for the first time in the history of chemistry that one element can really be transmuted into another, and it's above all which gives to the discovery of radium an importance which can be said to revolutionize chemistry and mark a new epoch. The theory of the absolute immutability of chemical elements no longer holds good now that science has succeeded in penetrating some of the mystery which has, until now, shrouded the evolution of the elements. The theory of transmutation, dear to the alchemist, has been unexpectedly restored to life, this time in an exact form, deprived of any mystical elements, and the philosopher's stone, with the property of inducing such transmutations, is no longer a mysterious, elusive elixir, but is something which modern science calls energy. The system of particles from which it must be assumed the atoms of radium are composed is charged with the most extraordinary quantities of energy. When the atom breaks down, these reveal themselves in the spontaneous development of light and heat, which is characteristic of iridium. Furthermore, we are no longer dealing here with a phenomenon which is unique or even unusual. The discovery of radium and polonium, an even more radioactive element, has brought in its train the discovery of a great many other radioactive elements with longer or shorter lifespans, by which our field of knowledge in chemistry and our understanding concerning the nature of matter has thus considerably extended. Indeed, research on radium has led during recent years to the birth of a new branch of science, radiology, which has already commands institutes and journals of its own in the great scientific countries. The science important in itself has acquired an added importance by virtue of its numerous points of contact with many other sciences such as physics, meteorology, geology, and physiology. We know that radium, because of its physiological effect, has found a use in medicine and to judge by a good many experiments, radiotherapy claims its most promising results, especially in the treatment of cancerous growth and of lupus. In view of the enormous significance that the discovery of radium has had for chemistry, then for many other branches of human knowledge and activities, the Royal Academy of Sciences considers it well justified in awarding a Nobel Prize for Chemistry to the sole survivor of the two Vikings to whom we owe this discovery, in this case, Madame Marie Skłodowska Curie. Madam, in 1903, the Swedish Academy of Science had the honor of conferring upon you the Nobel Prize for Physics for the part which you, together with your late husband, took a momentous discovery of spontaneous radioactivity. So this is the second Nobel Prize Madame Curie received, and still today, she's the only person who received a Nobel Prize for Physics and one for Chemistry. This is, of course, a summary. If you want to read the complete award ceremony speech, follow this link to the official Nobel Prize site. Here again, you see a view of the laboratory Madame Curie and her husband and their cooperators were working in, and another one. Well, this is it for the moment. Next week we will go into the Nobel Prize lecture given by Madame Curie in 1911. For now, thank you for watching, and maybe till another time.